There are two different types of ways we can investigate innate behavior. There is, especially when we're talking about organisms like invertebrates that don't have vertebrae or backbones or bones in general. So we're talking about insects and microorganisms. So there's two ways. Is something called taxis or kinesis. So taxis is a movement. Both of these are a type of movement, taxis and kinesis. So taxis is a directional response, which means that I know where I want to go. So for example, we're going to look at this organism that is one cell. It actually has both animal and plant qualities. It moves around like an animal and it eats things, but also it can photosynthesize. So it moves towards light with purpose because it wants to perform photosynthesis. So that would be an example of taxis. Kinesis, and I'm sure you've seen this with some organisms, some insects, just when they are exposed to a stimulus that they do not like, they will just move around randomly until they find a situation that feels better. So there's no real purpose with it. They just keep moving, moving, moving until they feel like they're in a position that suits their needs and their best chances for survival. Different types of taxis. So you can have taxis as it relates to temperature. You could have taxis as it relates to different chemicals in the water. I shouldn't say water, just chemicals in general. Or, as I mentioned before, phototaxis, which is in relation to light. And animals or organisms in general can move towards light. Some of them move away from light. Cockroaches, if you ever turned on a light and you saw a cockroach, they don't like light and they run away and hide. So it can be both. So these different taxis can be positive or they can be negative based on the situation. So let's look at a real quick phototaxis example. So in this example, the experimenter has some euglena. These are our photosynthetic one-celled organisms. And he puts a top on top of this petri dish. If you want to think of this as like a bowl, those of you that worked with petri dishes during your IA, looks like this. And we're looking down at the top. There's liquid in here, and we have our little euglena in here swimming around, right? So when we put this top on, and then we take it off, look at that. All the euglenas have moved to the spots where the holes were, thus the light got through. That is an example of positive phototaxis. An example of kinesis, which remember is just that random motion until they find a spot that feels okay, is with this animal called a woodlouse. So a woodlouse is this little guy up here. And believe it or not, it's a crustacean. They live on land, but it's a crustacean, so it means it has gills and it needs to be wet. And if it's dry, it's going to have a hard time. So if you put this woodlouse in a petri dish again, and it's dry, it is just going to randomly move around until it finds an area that's wet. However, if we had the same experiment and we had this woodlouse, this bug, in a moist environment, he's like, I'll just take my time. So then 30 seconds I was here, another 30 seconds I was here. And you can see over the time, this organism didn't move as much. So that's a good way to measure if the innate response is a result of kinesis, which is that random movement.